Only one language in the world, Japanese, that has a word for death by overwork, right? That's karoshi. That tells you a lot about not only Japanese, but how much you do not want to go work in Japan. So we came up with KITE. So KITE is the Karoshi interoperability testing engine, which is here to make testing of all those cases easy, and so that you not die by overwork trying to do it manually. So different people contribute with different goals. We wanted to test P2P communication between two WebRTC capable browsers at the beginning, with browser defining a loose term, right? So I will put media server in there. I will put WebRTC plugin for Internet Explorer there. There's a lot of small use case on the side. For the W3C, they wanted to test the JavaScript API because it's a mandatory step into the standardization process. So for WebRTC to become a standard, thanks God, please, quickly, and be fixed, we needed to show that it was implemented in at least two browsers at a level enough for interoperability and tested enough. So that's where the tested enough comes. But eventually, if you step back a little bit, everybody wants to try interoperability between any WebRTC capable client, being a native app, whether it is React or C++. I have no religion there, right? But you need to test them. If it's not tested, it's broken. The code is mostly open source. Everybody can use it, right? It's been paid for by Google so far and Cosmo, my company, but Colstat.io is starting to contribute, and Cisco, Microsoft, Apple have put that on their roadmap. So anybody here can get the test, set up their environment, and start testing, right? The idea is to make the differences between the differences in WebRTC implementation between the browser go down to zero, and make it easier for people to actually integrate and test WebRTC. How does it work? Most of the original problem with our test suite, and everybody test suite, is people start with something simple, and then they try to complexify it, right? And then they go in one direction, they get in another one, you got 20,000 patch, it's a problem. So we said, okay, based on what we know, can we actually cut things into modules that make people's life simple to start, but also make the maintenance easy? Because having a WebRTC application or SDK done right at a given time is easy. But keeping it working against the browser every 6 weeks when they update, that's the difficult part, right? So we're going to have different models. And the idea here is we want people to write one test, then say, I want to run this test against those browser configuration. And KITE is doing all the black magic for you of finding the configuration, make sure they're ready for WebRTC testing. There are some command line argument or different flag that you would otherwise need to know about, and and run it for you, right? Once this is done, they send you back the result in a JSON format. So if you want to integrate it into your own continuous integration system, be it. If you want to make a specific dashboard, it's fine as well. We didn't want to entangle or assume anything. So KITE doesn't know anything about the test you're providing. His job is just to check that the browser you're requesting exists and are available in a Selenium grid, and then run the test across, as much in parallel as possible. So that's where there's some added value. Edge and Safari, for example, only allow one browser per operating system. So every time you want one Safari to test or one Edge to test, you need to have a separate machine. Be it virtual or physical, doesn't matter. While Chrome and Firefox allow you to have multiple browsers running in parallel on a machine. So you can take an Amazon C8 extra large, but 50 of those there, and you're good. That explains why people usually start with Chrome and Firefox to test, and then when they try to extend to Edge and Safari, it's like, oh, that thing is different. It's going to be a little bit more complicated. KITE is handling that for you. So there is a parallel queue and a non-parallel queue. They know which one can be done in parallel. If you have in your grid only one edge, it's going to tell you that edge test is not going to be possible. And then it's going to schedule all the tests, including edge, in a non-parallel queue to make sure that you can handle it, right? So the load balancing over the grid is done automatically for you. It's pretty nice. Another way of seeing, of looking at the same thing, you have KITE in the middle on top, right? It's taking a test, a browser configuration, and a number of browsers, 1, 2, 3, 4, n. Do you know how many concurrent connections you can handle on your app? I know. It will know. soon. It's going to check that the Selenium grid attached can handle all the browser configuration, and you didn't ask for Chrome 125, which doesn't exist yet. And it's going to run there. So one of the magic there is that not knowing about the test, you can put in the test whatever backend support you want, right? So some people, when I was at Citrix, we had 3 different backend. We had a developer backend, a staging backend, a production backend. You might want to run different tests. KITE doesn't want to know about that. You should bring your own backend, right? So the test as a web app is the one decide to which backend you connect. And that's how you can actually handle different backend with the same test without rewriting anything, almost, right? If it's a web app, you pass it as a URL. You don't have to rewrite KITE. You don't have to support different browser. That's all the same. So it's kind of cool. When that is done, it's sending back the result. So this is all the, well, not all. This is the browser we support today. When we do the daily run for Google, Apple, Microsoft, and everybody, every day we actually test a series of tests for them. This is all the browser we support today. So those are only the desktop browser. So Chrome stable Ubuntu, Chrome stable macOS, Chrome stable Windows, then the Canary version, same for Firefox. Safari stable, Safari Tech Preview, Edge normal stable, Edge fast track, right, Insider Preview. You can add to that Chrome and Firefox on Android, Safari on iOS, Electron, and Qt. We have native Qt and some native app support. All that didn't come without problems. So Dan asked me to put the pictures because he was getting curious about how we actually do that. There's a lot of things you can do with virtual machine, but not everything. So for example, you do not have virtual machine with macOS unless you make it run on the macOS hardware, right? So you do not have macOS on any of the cloud vendor because of that. Well, that's fine. We got 20 Mac Mini. We got a few Mac Pro. We went Lego on that yet. That was the fastest part. You have a specific vendor in the US called Sonnet Technology that has some rack for Mac. That's what we bought. So they have rack for the Mac Pro, you can see here, and rack for the Mac Mini, and you do your own little cluster. And now Apple has agreed to give us actually some of the hardware to contribute to the working group, so to the browser testing and things like that, right? But originally, there was a lot of fun. You can do the same thing with Windows, because sometimes you actually need the physical machine, especially Edge doesn't support virtual cam yet. So if you want to test the get user media, today you're still stuck. So you have those Dell micro format. It's actually slightly smaller than a Mac Mini. It's kind of nice when you stack them. And otherwise you have the normal, big server, big footprint. So some example of what that do, using KITE as a one browser configuration, we could run the web platform test, which is the testing suite for the W3C. So on the right-hand side, you had what they did before, and you can see there is only 4 configurations, and it's not updated every day, right? On the left-hand side, you can see a specific dashboard with the 21 configuration that KITE supports. So we run, the 2 days of work were 1 day to actually wrap the web platform test into a KITE test. So there is a little bit of Java wrapper, so we can pass it on to KITE. And 1 day to do the color and the dashboard so it doesn't look as ugly as the original one. The advantage is when that is done, you can run it on all the possible configuration with no added work. And that's the added value of KITE. That's where it's making your life simpler, is that you don't have to care about the browser anymore. A 2 browser example, WebRTC. That's what we run daily. And you can see the result on WebRTC.org on the testing section. So all the configuration, you have the result as a row, or you have the result as a list. And if you click on the specific one, you also have that screen on the left, which is parsing of all the stats and the SDP and so on and so forth. So you can, with a few clicks, you don't have to open 3 different log files and go fish, which identifier is which and where is the problem. Another 2 browser examples, thanks to our friend at callstat.io. Callstat.io had enough of people coming to them and say, you think it's broken, when it was actually most often the browser that didn't do the right thing or that was breaking things. So they took KITE and they implemented a test, exhaustive test for all the possible stats returned by GetStat by all the browsers, right? And they did a nice user interface to actually fetch the result and be able to compare. So if one day you have a problem with the stat, you can go there and check if that's not actually a problem with the browser, in which case your app is not to blame. And one of the things they realized very quickly, for example, is that the NAC was implemented for video on the left, but not for audio, and that was a Chrome bug, and they reported it, right? So all of that eventually will make the browser better and the implementation better across. But that's nice tools to have to be able to quickly know if you are facing browser regression or if you are facing a problem with your own app. To be able to do that, you need to be able to do it across all the browsers, right? Free browsers, we did a quick GT run with only 3 people. We could do more, we did. We know where it breaks, but we're not going to tell it today. So the latest tests we did were tests that were requested by the browser vendor to help them implement the latest, right? So multi-party, multi-stream, and simulcast. There's a little bit difference between the 3, but basically it's about how you bundle them. Do you have those 3 wires in 3 different plastic protection, or do you try to put them in one big one, right? And simulcast is even a little bit different because it requires a media server, right? Multi-party and multi-stream can be peer-to-peer, but for simulcast you need a media server. And so we had to implement a different kind of test that communicates between a browser and an SFU. All of that in place, that is addressing right now, hopefully, the difference between Unified Plan and Plan B for those that went there and suffered already. And the goal was to help Google deliver Unified Plan faster, which I believe they are, even though it's never going to be fast enough. A new things we're doing, again, with input from Callstat.io, is network instrumentation. When we have all those tests, we're only testing from the outside, right? A lot of problems come from networks issue, right? Whether bandwidth fluctuation, configuration of NAT and firewall, or quality. So latency that is varying, packet loss, jitter. I think Boris illustrate a few of the things. So simulcast is a way to address that. But how do you test simulcast? So if you're on one operating system with one given tool, let's say macOS with network limiter, you can test. But how do you test exhaustively on any configuration, on any operating system for any of the browsers? So all of the metrics I said before. So independently for each of the client connecting, possibly for the server itself, even though that's less of a problem because most people put the server on a public IP or in the cloud and so on, where you can control of the settings so you know most. And for every operating system, a browser is available, right? Some people have tried that before. So entity communication had a virtual private network approach. Elastest, which is a European Union project that was started from Currento testing framework, use Docker, but you have a problem of scope or a problem of operating system or link, right? You don't want any of those links that goes between Alice, Bob, and all of the server to be on the public internet, otherwise you don't control it, right? You want all the operating system and so on and so forth. So this is not a solved problem yet. If you look at the different possibility, there is always a case where you either do not control the network, manage network, or you cannot support a specific client, right? We're investigating right now of a way to actually make sure we can transparently, so with a unified API, control all those network, instrument and automate the network across the client and for all the links. So the idea is like, okay, start with 2 megabytes, right? And then suddenly drop the bandwidth to 500K and see if what we expect to happen, right? Is simulcast kicking in, right? Is everything going okay? Is my resolution going down? Is my codec doing the bitrate adaptation like it should? Without that, you cannot test the ramping up, you cannot test simulcast, you cannot test SVC, and so on and so forth, right? So that's what we're working on right now. Another problem, much less for the video conferencing, but for the streaming application, is load testing. So with KITE, we already did the work of instrumenting all the browser on all the operating system and so on. Now we have a volume problem, right? The latest publication I could find on the subject, again by the Elastis team, mentioned that one of the most demanded service in the WebRTC arena was broadcasting, but they could only test up to 200 viewers. We saw some tweets from House Party and other people where they could do 100, maybe 1,000. Test RTC is claiming 1,000, for example. But the problem is if you look at actually the volume for people that do streaming, not WebRTC, but eventually would like to replace, Super Bowl viewers, 100 million. Game of Thrones, 10 million. That guy sponsored by Red Bull jumping out of a capsule in space to whatever, 1 million, right? So our goal was to get close to 1 million. How can I actually spawn 1 million browsers, you know, and load test a platform? In the video conferencing mode, it's almost impossible because if you get too many streams on a browser, the rendering process is eating all your CPU. But on the streaming mode, you client are only receiving one stream at a time. So you do not have any limitation or any excuse on that side anymore, right? So, long story short, we didn't get to 1 million. We're somewhere between 100K and 500K today. And we keep pushing the boundary, but it's still cool. Nobody, as far as we know, has been doing that in the Selenium world because Selenium was used more for, you know, individual application testing one browser at a time. So that kind of scalability was unheard of. And so people that are interested in those details, that will be presented at Selenium World in October in Chicago, right? We tested most of the open source SFU, MediaSoup, Inaki right here, Janus, Lorenzo, Miduz, GT, you know, and Currento Media Framework. That's how they call it, I think. On the video conferencing mode, and then we did separately a run on streaming, WOSA, Red 5, N5, you know, people from the Flash world that support WebRTC. And I'm not going to tell you what the limit of each server is, but you know, we plan to publish that at IPTCom. People that want an early view at the result, we're happy to share. We just do not share publicly because it's not published yet, right? And of course, we did that with all the teams, so we're going to share with everybody, with the respective team, the result of their test. We have a platform in production called millicast.com, where we actually have up to 50,000 concurrent viewer per performer, per content provider, right? So there's much more across the platform, but for a given stream, you can have up to 50,000 viewers. It's not very impressive for people in the streaming world. People that do HLS or Flash could do much more than that very easily, but it took 20 years for them to get there. In the WebRTC world, I don't know about anybody else that can do that, even though Red 5 claimed to be able to do 100,000. We could not reproduce that result independently. We had to make more instruments, so now we have a grid manager. We do not have 1 million Chrome instance sitting around in Amazon waiting for us to use them. That will be a little bit costly. So now instead of having a static grid and physical device, we have an on-demand grid. So KITE learned how to spawn Amazon. So you provide an account in Amazon Web Services, and then KITE is going to spawn the browser you request, and you have a grid manager that allows you to check bandwidth, CPU, and everything you would like to see. Since it's load testing, you want to see what happened on the back end and not what happened in the client anymore. So we had an extra tool for that. But it's super cool. So, wrap it up. If you want to test interactive website, I spoke about WebRTC, but if you had a chat, that would be exactly the same, right? You have two browsers that speak to each other, that need to be kind of synchronized and automated together, right? If you want to test across multiple browser configuration without even thinking about it, problem solved. If you want to test your Electron clients, I don't know about any other way to do that today, any other automated way to do that today. If you want bugs never to reach stable version of browser, that's something I didn't speak about, but most of the people catch the bug when they arrive in the stable Chrome or stable Firefox, and it's too late to fix them. So if you report a bug in stable Chrome or stable Firefox, you need to wait 2 or 3 revisions before the patch comes in, if there is a patch. So the only way to get the patch in right away is to catch the bug in Canary. So if you catch the bug in Canary and you provide a patch, it goes in right away. If you catch a bug in the in-between, I don't remember if the name is developer version or beta, it only gets in if it's judged critical by the browser vendor team. And if you catch it in stable, well, you have to wait for the current Canary to become stable, which is 2 cycles of 6 weeks, right? So KITE, by allowing to test across multiple browsers, including Canary, make that easy for you, right? If you want freedom to run it yourself, because that thing is open source and can run on premises, on your own data center, if you want to test your own geolocation or things like that, use specific links, you can. But if you want to load test or benchmark your site, possibly against the competition, I mean, KITE is, I think, the perfect tool for you. Right, and we have 10 minutes for questions. Yes?
For those of us that are new to WebRTC, can you explain the difference between the unified plan and the or is that just like, don't go...
Okay, I can...
The 5 minutes we have left.
What do you do for the rest of the week? No, I will give it to you short and sweet. Multistream is the capacity to send multiple media stream inside one peer connection. To be able to do that, you need to tell the other side, hey, there is multiple media coming your way. So you need to be able to signal to tell the other side that's coming your way, right? There was no specification for that. So Chrome went ahead and did the first implementation with something called Plan B. And then people finally end up with a specification that was Unified Plan. So Chrome was the first one for historical reasons. They had Plan B. Safari took the code for Chrome, so they also have Plan B today. Firefox came later to the game, and because they came later, at the time of implementation, decided to go with the standard that was Unified Plan. Now, everybody is supposed to eventually implement the standard Unified Plan, but that has been taking a little bit longer than people thought it would. It's supposedly in progress. So for historical reason, Chrome and Apple use Plan B. The right thing is Unified Plan that Firefox uses today, and Chrome is going there. As soon as Chrome has done the work, Apple is going to take it and put it in Safari. I'm not going to speak about Edge. Yeah. Not controversial. Yes, we wish we didn't know more about that either. It's a very emotional topic, quite intense. All right.